Welcome to the video tutorials of mechanisms by me Miller. In this video I will try to explain the working principles of a rocket and rocket engine. A rocket has four main parts. The first part is the payload. The payload can be anything from a satellite, a warhead, and human beings for the space exploration. The second part is the fuel tank, which is a huge tank filled with liquid hydrogen or any other type of fuel. The third part is a huge oxygen tank which allows the rocket engine to operate in an airless environment such as space. The fourth and most complex part of the rocket is the rocket engine. The main parts of the rocket engine are: start tank, mixing tank, turbine for generating power for the pumps, fuel boost pump, oxygen boost pump, combustion chamber, throat, nozzle. Let's describe the working details of the rocket engine. During the ignition process, the material inside the start tank creates enough pressurized gas to operate the turbine. The turbine is coupled to the fuel and oxygen pumps. Therefore, the operation of the turbine forces the fuel and oxygen to the combustion chamber by using pumps. Once the fuel and oxygen are mixed in the combustion chamber, it is ignited and the operation of the engine starts. At the same time, a small portion of the fuel and oxygen are diverted to the mixing chamber. Fuel and oxygen mixture is ignited inside the mixing tank to create pressurized gas to power the turbine. The outlet of the turbine is connected to the exhaust pipe to discharge the expanded gases to the environment. This process continues as long as their fuel or oxygen is in the tanks. As many of you may know, rockets work with the same principle as a fire hose. When you hold a fire hose, you will experience thrust on your body in the opposite direction of the water flow. This thrust is proportional to the speed and amount of water being discharged from the hose. The bigger the flow rate or faster the flow speed, the more you will experience thrust on your body. For a rocket, the higher the amount of fuel and oxygen disposed from the nozzle, the more thrust will be generated for the same exit velocity of gases. Thrust generated by exit gases is also proportional to the speed of the exit gases. The faster the gas flow from the nozzle, the more thrust will be generated. Now, there is one problem here. We know that to make water flow faster we have to make the exit hole as small as possible. However, with the rocket engine the nozzle expands and the exit area actually gets larger. You may think that would reduce the speed of the exit gases, but on the contrary, compressible gases do not behave like water. Instead, when the flow area of pressurized gas decreases, its velocity will increase. This process continues until the speed of the gas reaches the speed of sound. At which point reducing the area causes shock waves to be generated inside the nozzle. To prevent shock waves from generating and to increase the gas velocity, the area of the nozzle must be gradually increased. We call the area where flow speed is going from subsonic to supersonic the throat of the nozzle. This phenomenon is very strange, but it's true. Not shown in this video are the cooling pipes from the fuel pipe circling around the nozzle. These pipes preheat the fuel while it's cooling the nozzle. Thank you for taking the time to watch our video. If you enjoyed this video and found it to be useful, please subscribe to my channel and hit the like button. We appreciate your support.